Hello guys, you are welcome. In this video, we will be treating the topic of permutation and combination. Before we begin, if you haven't subscribed to this channel yet, please go ahead and subscribe now. And don't forget to turn on the notification bell so you'll be alerted whenever we upload new videos. Now, let's get into the business of this video. We'll first consider the concept of factorials. Factorial n, denoted by n factorial, is the product of all the integers starting from n down to the positive integer 1. Note that n must be a positive integer. For example, 5 factorial is equal to 5 times 4 times 3 times 2 times 1, which is equal to 120. So for any given positive integer, say 6, 7, whatever, you start from the given integer and then you find the product down to 1. Now, it's also important for you to note that 0 factorial at any given point is equal to 1. Very important. Note that. 0 factorial is equal to 1. Just note that. Now, let's move on to permutations and combinations. In mathematics, arranging, also called permuting, and combining, also called selecting, are two related but distinct activities. Items are combined or selected in no particular order, but arrangements, which is also called permutations, are all about order. So you can say that combination is selection without considering order, and permutation is arrangement in which order is relevant. For example, there is only one combination of the first 3 letters of the alphabet A, B, C, if we are not concerned about their order, whereas there are 6 arrangements if we consider their order. In arrangement or permutation, the order in which items are listed are relevant, but in a combination, the order is irrelevant. So that whilst ABC and CBA form distinct arrangements, they both form the same combination if we are not concerned with order. Now let's move to the mathematical representation of permutation. N permutation R is the arrangement of n objects taking R at a time. And the formula for this is n PR equal n factorial over n minus R factorial. That's the formula for permutation. Now, applying this to the example of the first 3 letters of the alphabet we discussed, that's ABC, giving A, B, C, our n, the total number of objects, is equal to 3. And then our R, the number of objects we are considering for arrangement at this particular time, it's still equal to 3. So we have 3 objects, and 3p3 is equal to 3 factorial over 3 minus 3 factorial, which is equal to 3 factorial over 0 factorial. Remember, we already stated that 0 factorial is equal to 1. Then we have 3 times 2 times 1, which is equal to 6. So remember, in the different arrangements we showed of ABC, we had 6 different arrangements. Now it's important to note that the arrangement of n objects, taking all n at once, is equal to n factorial. Just like we have with the case of ABC. We are arranging 3 objects, taking all 3 at a time. And all of this is basically equal to 3 factorial, which is still equal to 6. So note this. This is very important. Now we'll consider the types of permutation. There are 4 types of permutations we'll consider. Number 1, arrangement of distinct objects. Number 2, arrangement of objects that include identical objects. Number 3, cyclic permutation. And finally, conditional permutation. Let's go into the first one, arrangement of distinct objects. This is for instances where we are given a set of objects where all the objects listed are distinct. Now let's try some examples. Example number 1. We are asked to find the number of possible arrangements of the letters of the word notable. Notable. Now if you look at the word notable, you find out that all the letters, that's the objects listed here, are distinct. There's no letter repeated. So this is a case of distinct objects. So how do we find the arrangements, the number of possible arrangements of this? We count how many objects do we have. 1, how many letters? 1, 2, 3, 4, 5, 6, 7. Now, this is the case of NPN, which is equal to n factorial. So we have 7 objects, and the permutation is basically equal to 7 factorial. 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1, which is equal to 5040. So there are 5040 ways to arrange the letters of the word notable. Let's consider another example. Number 2. Find the total number of different arrangements using any 3 letters of the word chemistry. In this case, we have the word chemistry. How many letters or objects do we have in the word chemistry? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Our n is equal to 9. And then note that the question says using any 3 letters. That means in this case, our r is equal to 3. So using the formula NPR equal to n factorial over n minus r factorial. What we'll have 9 P3, which is equal to 9 factorial over 9 minus 3 factorial. This is equal to 9 times. This is equal to 9 factorial over 6 factorial. Sorry, this is 9 factorial. Let's take everything step by step. Now 9 factorial over 6 factorial is equal to 9 times 5 times 8 times 7 times 6 factorial. That is 6 can go on to 1 over 6 factorial. So 6 we basically cancel 6. So we're left with 9 times 8 times 7, which is equal to 504. So there are 504 different arrangements using any 3 letters of the word chemistry. Up next, we'll consider the arrangement of objects that include identical objects or identical elements. In this case, our number of arrangements, P, will be equal to n factorial over r factorial, where n is the total number of objects and r is equal to number of identical objects. Now let's go into some examples. Example 1. In how many ways can you arrange the word Anambra? Example 1. The word given is Anambra. How many letters are here? We have 1, 2, 3, 4, 5, 6, 7. N is equal to 7. How many identical letters do we have? 3. That's just our A. We have 3 A's. 1, 2, 3. So R is equal to 3. So the number of arrangements, P in this case, is equal to 7 factorial over 3 factorial. This is equal to 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. All of this is equal to 3 factorial, cancel this. So we have 7 times 6 times 5 times 4. Which is equal to 840 ways. Now for our second example, we are asked how many arrangements are there using all the letters of the word letters. Letters. We have the number of letters here, objects. We have 1, 2, 3, 4, 5, 6, 7, and is equal to 7. Then, if you notice, we have two sets of identical letters, which is E and T. So our R for E is equal to 2. And then our R for T is still equal to 2. So in this case, the total number of arrangements will be equal to n factorial over RE factorial times RT factorial. So this is equal to 7 factorial over 2 factorial times 2 factorial. You expand this and you have 7 times 6 times 5 times 4 times 3 times 2 times 1 over 1 times 2. Sorry, 2 times 1 times 2 times 1, which is all equal to, by the time you evaluate all of this, you have 1,260 ways, arrangements. The third type of permutation is a cyclic permutation, and this is the arrangement of objects in a circle, and it has a simple formula. P equal to n minus 1 factorial. So giving an example, take for example, in how many ways can 6 people take places at a round table? Round table is a circle, so our P would be, how many people do we have? Our n is 6, simply 6 minus 1 factorial is equal to 5 factorial, which is also equal to 120 ways. That's simple. And finally, we have our conditional permutation. This is like the first 3 permutations, but with conditions attached that must be satisfied. Now, let's do some examples. We're given there, in how many ways can you arrange the word Anambra if the 3 A's must stay together? The condition there is if the 3 A's must stay together. So we have the word Anambra. If the 3 A's must stay together, first of all, remove the A's to have N, M, B, R. So if the 3 A's must stay together, that means they count as one entity. So, and they can be here, they can be here, they can be here, they can be here, and here. First of all, we'll find the permutation of the other letters apart from A. So that we have 1, 2, 3, 4. So the permutation of the other letters is 4 factorial. And then, since the A's are together, they can be arranged in 1, 2, 3, 4, 5 ways. So that's 4 factorial times 5, which is equal to, that gives us 4 factorial times 5, which is equal to 4 times 3 times 2 times 1 times 5. This is equal to 120 ways. Example number 2, we are asked to find the number of ways in which the letters of the word shallow can be arranged. We are given 2 conditions. A, if the 2 L's must always be together. This is like in the case of the first example. And B, if the 2 L's must not come together. Our word is shallow. The L's are the only identical letters. So let's remove the L's. Removing the L's, we are left with how many letters? 1, 2, 3, 4, 5. So these 5 letters can be arranged in 5 factorial ways. And then, if the L's are to stay together, this is for A now. If the L's are to stay together, they count as one entity, and they can be in any of these places, which is 1, 2, 3, 4, 5, 6. That's 6 ways. So our answer is equal to 5 times 5 factorial times 6. This is equal to 720 ways. Now for the second condition, say if the 2 must not come together. Now we'll still have so our L's can be in any of these places. That's the 1, 2, 3, 4, 5, 6. So in this case, we take all the possible arrangements for the other letters apart from L, which is still 5 factorial. And then, giving 2 L's apart, the first L can be put in 1, 2, 3, 4, 5, 6 ways, leaving 5 other ways. So the second L can be put in 5 other ways. But then, this is not where we'll stop. You know that the 2 L's are identical, and you can't tell them apart. So you can't tell which one goes first. So the order doesn't matter. So we'll divide, since there are 2 of them, we divide it by 2. The order does not matter. So this is equal to 5 times 4 times 3 times 2 times 1 times 6 times 5 over 2. Answer here is. So the answer here is 1,800 ways. Here's an exercise for you to try yourself, and the answers are given there. So now let's move on to the mathematical representation of combination. Mathematical representation of combination. NCR, that's n combination R, is the selection of n objects taking R at a time. Formula for NCR is equal to n factorial over n minus r factorial times r factorial. This is a formula for combination. Now let's try out some examples. We are asked to find the values of 4 combination 2, 8 combination 4, 4 combination 4, and 3 combination 0. Now, using this formula, 4 combination 2 is equal to 4 factorial over 4 minus 2 factorial, 2 factorial. This is equal to 4 factorial over 2 factorial times 2 factorial. This is equal to 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. All of that is equal to 6. Second, we are asked to find the value of 8 factorial. 8 combination 4 is equal to 8 factorial over 8 minus 4 factorial, 4 factorial is equals to 8 factorial over 4 factorial, 4 factorial. This is equal to 8 times 7 times 6 times 5 times, permit me to stop here, 4 factorial over 4 times 3 times 2 times 1 times the second 4 factorial. So this equals to this. By the time you evaluate this, you will have that this, all of this is equal to 70. Number 3. There's just 2 more, but I'm sure you get the gist by now. 4C4, 4 combination 4. 4 factorial over 4 minus 4 factorial, 4 factorial. This is equal to 4 factorial over 0 factorial, 4 factorial. Remember, 0 factorial is equal to 1. So this is the same thing as 4 factorial over 4 factorial, because 1 times 4 factorial is 4. So this cancels this, and we are left with 1. Then finally, we have 3C0, 3 combination 0. This 3 factorial over 3 minus 0 factorial, 0 factorial. This is equal to 3 factorial over 3 factorial. Remember, 0 factorial is equal to 1. So this is equal to 1. Now, let's head on to some applications. Now, we have this question here. From a group of 30 students who offer Math 111 and Math 121, 3 are to be selected for an award. In how many ways can the 3 students be selected if 1 must receive the award? Now, this is a case of conditional combination. We are asked to select 3 students for an award, and then the condition there is that if 1 must receive the award. So, out of example 2, out of our 30 students, 1 is already slated to receive the award. That means we are left with a sample space of 29 students, and we are to pick 2 from the 29. So this is equal to 1 times 29 factorial over 29 minus 2 factorial times 2 factorial. This is equal to 1 times this is already 29 factorial over 27 factorial times 2 factorial. 29 times 28 times 27 factorial over 27 factorial times 2 times 1. 27 factorial cancel out 27. So we are left with 29 times 28 over 2, which is equal to 406 ways. So there are 406 ways to select 3 students for the award if 1 student must receive the award out of 30 students. This is our final answer. So here are some exercises for you to practice with. If this video was helpful to you, kindly like and share it with your friends and colleagues. And if you have any questions or run into any difficulty with the exercises or explanations, please drop a comment below. I'll be glad to respond. Thank you.